hopefully we still remember how to solve quadratic equations. Now, these are, as we hopefully remember, equations in the form of ax squared plus bx plus c equals 0, usually. Or can be rearranged to look like this, or simplified, or expanded, etc. So, a, b, and c are real numbers, and a is not 0, because if a was 0, this would be a linear equation instead of quadratic. Now the discriminant is this expression here, and this can immediately tell us the number of solutions to a quadratic equation. If it turns out that this is less than 0, then there are no real solutions. If this is equal to 0, then there is one real solution, or technically two identical solutions. If this is greater than 0, then you have two distinct real solutions. Okay, so when you're solving a quadratic equation, there are four methods you can use. One is factoring. The second is completing the square. The third is using the formula, so quadratic formula. And fourth is graphing with a calculator. Honestly, if you can use factoring, you shouldn't bother with any other ones. If you can solve it by completing the square, that's great. If you have to use a formula, okay. But honestly, graphing with a calculator should really be avoided if possible, for the simple reason that many exams, even not just contests, even some exams will not be tolerant of graphing calculators, which is of course not so good, yes, for people who are too used to using graphing calculators. Okay, so let's solve these by factoring. Now when we factor, what we are looking for is, so let's say we factor this to be x plus r and x plus s. What does this come out to? This comes out to x squared plus r plus s times x plus rs. So what we're looking for is this part here is bx, and this here is c. So we should make sure that the coefficients in front multiply to a, and the ones in the back multiply to c, and through some combination of this times that coefficient plus this part, this coefficient here, times that constant, we need to somehow add to v. However, factoring is not the end of this problem. Why? Because, oh hey, what we have to do now is state that x equals 2 or x equals 3, because one of these two has to be equal to 0 for this to hold true. That's why we're solving this. We're finding the solutions. So here, 21 is 3 times 7, right? How do we combine 3 and 7 in such a way as to make 4? Hey, wait a second, this is minus 1. That means we have a plus 1 and a minus 1, most likely. Which means, hey, plus 7 minus 3 is so x equals negative 1/3 or x equals 1/7. Now, depending on teacher and how experienced you are at this, it might be the case that when you are first learning this, way back, you had to write, oh, 7x minus 1 equals 0, and then x equals 1/7. But here, I don't require that. Your teacher, on the other hand, well, results may vary. So, solve by completing the square. completing the square is a matter of, hey, 6x plus 9. We remember how a plus b squared is equal to a squared plus 2ab plus b squared? Well, x here is essentially a, and to get b, how do we get b? We take this coefficient and divide it in half, because this here it would be 2b. So this is 6, and x plus 3 squared equals 6. So x plus 3 equals plus minus square root 6. X equals negative 3 plus minus square root 6. Okay, so next let's solve some by quadratic formula. Quadratic formula is this thing. It always works no matter what you do, as long as the thing actually has real solutions, or at least one real solution, i.e. the discriminant here isn't negative, because taking the square root of a negative number gives us an imaginary number, not a real number. So here, let's do this by way of the quadratic formula. X equals negative b plus minus square root b squared minus 4ac over 2a. So negative 6 plus minus root 6 squared minus 4a, 4 times 1, and c, which is 3. So over 2a, so over 2, equals negative 3 plus minus root of 36 minus 3 times 4 is 12 over 2 equals negative 3 plus minus root 24 over 2 equals negative 3 plus minus root 6. Lo and behold, it is exactly the same as what we got up here. Now, some people will ask you to write, oh, x1 equals negative 3 plus root 6. x2 equals negative 3 minus root 6 for the two separate solutions. Most teachers will not require this, or should not require this. So here we have another example, and x equals negative b squared minus 4ac over 2a equals negative 7 plus minus root of 7 squared minus 4a, and c is negative 9 over 2a. So 2a is 2 equals negative 7 plus minus root of 49 plus 4 times 9 is 36 over 2. Negative 7 plus minus root of 85 over 2. You don't even have to pull the fraction apart for most teachers. Now, sometimes we can take a glance at a problem and get the feeling that something's a little bit off about it, and we can avoid doing the problem altogether if we can demonstrate that the discriminant has a value that is less than 0, and thus there are no real roots to the problem. If there's one root, technically that's actually two equal real roots because it's plus minus 0, or plus minus root 0 rather, which is 0. And if there's a value for the discriminant that's greater than 0, then we have two real roots, or rather two distinct real roots. So here we're going to use a discriminant to determine the number of solutions for each quadratic equation. So the discriminant is delta, or sometimes written as d, equals b squared minus 4ac, which is 5 squared minus 4 times negative 3 times 7. So this is 25 plus 84. This is equal to 109. So we write that there are two real roots. Some teachers will ask you, at least at the start, to justify by adding as delta is larger than 0. Okay. X squared plus 6x plus 9, we would have delta equals b squared minus 4ac. This would be 6 squared minus 4 times 1 times 9, which is then 36 minus 36 equals 0. As delta equals 0, we have one real root. Technically, it's two identical real roots, but honestly, nobody cares about that for the most part. So here, we can find that delta equals, you can probably predict where this is going. So b squared minus 4ac equals 3 squared minus 4 times a times c. So that's 9 minus 4 times 5 is 20 times 7 is 140. Negative 131. So as this is less than 0, we have no real roots. So hopefully we have managed to review quadratic equations sufficiently that we shouldn't have any problems determining what the root values are, or whether there are roots pretty much at a glance by doing a relatively quick calculation compared to the entire quadratic formula. And that's it for this section. Next section we will talk a little bit more about quadratic review. So see you next section.